Hello students, today we shall see some more examples on radius of curvature, and also we shall see finding radius of curvature at origin by Newton's method. So first we see some examples. Example number 6. If ρ1 and ρ2 are radii of curvatures at the extremities, that is endpoints, of any focal chord of the parabola y square equal to 4ax, then show that ρ1 to the power minus 2 by 3 plus ρ2 to the power minus 2 by 3 equal to twice a to the power minus 2 by 3. So given parabola is y square equal to 4ax, differentiating with respect to x, we get derivative of y square is twice y into dy by dx, and derivative of 4ax is 4a. Derivative of x is 1. So dy by dx is twice a by y. Now again differentiate, we get d square by dx square is equal to twice a into 1 by y, derivative is minus 1 by y square into dy by dx, chain rule. Now we have to consider a focal chord. Let p with coordinates a t1 square comma twice a t1. See, parametric equation of this parabola y square equal to 4ax is x equal to at square, y equal to twice at. So coordinates of any point on the parabola can be taken as at square comma twice at. That's why we have taken p with coordinates at1 square comma twice at1 and q with coordinates at2 square comma twice at2 be the extremities of a focal chord, endpoints of a focal chord of the parabola. Then we know t1 into t2 equal to minus 1. This is a standard result from coordinate geometry. T1 into t2 equal to minus 1. If p and q are extremities, endpoints of a focal chord. Focal chord means chord passing through the focus. Focus of this parabola is S with coordinates a comma 0. So if the chord passes through the focus, then its extremities, coordinates of its extremities are at1 square comma twice at1 and at2 square comma twice at2. If we assume, then t1 into t2 is minus 1. This is a standard result. Okay, we shall use it. Now at this point p, dy by dx is twice a by y means here twice a t1, so it is 1 by t1. d square by dx square is twice a into minus 1 by y square, so it is minus twice a by y square into dy by dx. So minus twice a by y square means twice a t1 square, and dy by dx already have got 1 by t1, so value is 1 by t1 substituted, and just simple simplification we get minus 1 by twice a t1 cube. Therefore radius of curvature of the parabola at this point p is given by, let us denote it by ρ1. ρ1 equal to 1 plus dy by dx square to the power 3 by 2 by d square by dx square. Formula for radius of curvature, and putting the values of dy by dx and d square by dx square, we get this, and a simple simplification gives it is minus twice a into t square minus 1 to the power 3 by 2. But radius of curvature is always measured positive. So ρ1 is positive, so we take ρ1 equal to twice a into t1 square plus 1 to the power 3 by 2. Similarly, radius of curvature at the point q with coordinates at2 square comma twice at2 will be exactly similar to this, only t1 will be replaced by t2. So that is given by ρ2 equal to twice a into t2 square plus 1 to the power 3 by 2. ρ1 with t1 and ρ2 with t2. Other things remaining similar. Okay, ρ2 is with t2, and t1 t2 is minus 1, so t2 is minus 1 by t1, so if you square it, it will be 1 by t1 square. So this is our ρ2. Now you want to show ρ1 to the power minus 2 by 3 plus ρ2 to the power minus 2 by 3 equal to twice a to the power minus 2 by 3. So we start with this. So ρ1 has factor twice a, ρ2 has factor twice a. So ρ1 to the power minus 2 by 3 plus ρ2 to the power minus 2 by 3 has the common factor twice a to the power minus 2 by 3, and here t1 square plus 1 to the power 3 by 2, if we make it raise it to the power minus 2 by 3, it will be minus 1, so it is minus 1. Similarly here it will be 1 by t1 square plus 1 to the power minus 1, and then law of indices, it is 1 by t1 square plus 1. Here if we take LCM, it will be 1 plus t1 square by t1 square, but power is minus 1, so it is t1 square by t1 square plus 1, and then it is 1 plus t1 square by t1 square plus 1 means it is 1. So finally we have got twice a to the power minus 2 by 3. Therefore ρ1 to the power minus 2 by 3 plus ρ2 to the power minus 2 by 3 equal to twice a to the power minus 2 by 3. Shoot. Next example number 7. Find the radius of curvature at any point of the curve. First curve is x equal to a into theta minus sin theta, y equal to a into 1 minus cos theta. Here theta is parameter. This is parametric equation of a curve. And number 2 is x equal to a into cos t plus t sin t, y equal to a into sin t minus t cos t. Here parameter is t. This is also parametric equation of a curve. Now let us do Roman 2 first. X equal to a into cos t plus t sin t. X dash means dx by dt, derivative with respect to t. Derivative of cos t is minus sin t, and t into sin t is product rule, u into v rule. So derivative of t is 1, sin t remains, plus t remains, derivative of sin t is cos t. Now this minus sin t and this sin t gets cancelled, so we get at cos t. X dash. Then x double dash means d square x by dt square. Again we differentiate this at cos t, product rule again, t into cos t. So a constant remains. Cos t, derivative of t is 1, cos t remains, plus t remains, derivative of cos t is minus, that's why minus sin t, that's why it is minus. Now y equal to a into sin t minus t cos t. So again y dash is dy by dt is sin t derivative is cos t, and t into cos t derivative. T derivative is 1, so it is minus cos t. Then t remains, cos t derivative is minus sin t, but already there is a minus sign, so it is plus t sin t. Now this cos t gets cancelled, so we get a t sin t. So y dash. Then y double dash means d square by dt square. Again we differentiate this line with respect to t using product rule. Derivative of t is 1, so sin t remains, plus t remains, sin t derivative is cos t. Got. So x dash, y dash, x double dash, y double dash we have calculated. Now rest is only to put these values in the formula. Therefore required radius of curvature is given by rho equal to, formula in parametric form is x dash square plus y dash square to the power 3 by 2 divided by x dash y double dash minus x double dash y dash. X dash is at cos t, so x dash square is s square t square cos square t. Y dash was at sin t, so it is s square t square sin square t. Okay, x dash value is at cos t, and y double dash is, we have seen here, a into sin t plus t cos t substituted. Similarly value of x double dash a into cos t minus t sin t, and value of y dash is at sin t substituted. Then s square t square common, cos square t plus sin square t is 1, so it will be only s square t square to the power 3 by 2 means a cube t cube. See, a cube t cube is there. Then denominator a into a s square t common, here a into a t, s square t common, and this cos t taken inside, cos t sin t plus t cos square t, and here this sin t taken inside, minus cos t sin t and minus minus plus t sin square t. Okay, so these two terms gets cancelled. Finally again if we take t common, it will be s square t square, sin cos square t and sin square t added here, sin square t plus cos square t is 1, so finally answer is 80. So this is radius of curvature at any point of this curve. Then we see Roman 1. Here parameter is theta. We shall differentiate with respect to theta now. X equal to a into theta minus sin theta, y equal to a into 1 minus cos theta. So x dash means dx by d theta this time. So theta derivative with respect to theta 1, sin theta is cos theta derivative. Okay, then a into 1 minus cos theta, 1 derivative of 1 is 0, cos theta derivative is minus sin theta, so it becomes plus a sin theta. Then x double dash is derivative of cos theta is minus sin theta, so this will become plus, means a sin theta, derivative of 1 is 0. Here y dash is a sin theta, so y double dash will be just sin theta, derivative is cos theta. Okay, now therefore radius of curvature of the curve at any point is given by putting this values of x dash, y dash, x double dash, y double dash as before in the formula for radius of curvature in parametric form. We get this. Now if we square this 1 minus cos theta, whole thing square is 1 minus 2 cos theta plus cos square theta. This s square taken common, but there is a 3 by 2, so means it will be a cube common. Denominator is a square common, cos theta take inside, cos theta minus cos square theta here, minus sin square theta, so we have taken minus common, cos square theta plus sin square theta 1. So in the numerator what you see, cos square theta plus sin square theta is 1, there is a 1, 2, and minus 2 cos theta, so 2 common, 1 minus cos theta. Denominator is cos theta minus 1, but we have written 1 minus cos theta with taking minus sign common, so that 1 minus cos theta in the numerator, denominator similar. So rho becomes this a cube and a square cancelling, we get a here only, and 2 to the power 3 by 2, and 1 minus cos theta to the power 3 by 2, and 1 minus cos theta, if we use law of indices, it is 3 by 2 minus 1, means only half. Okay, so 2 to the power 3 by 2 is 2 root 2, so minus 2 root 2 a, and 1 minus cos theta is 2 sin square theta by 2 to the power half, means it is root 2 sin theta by 2. So finally 4 minus 4a sin theta by 2, but rho is measured positive, that's why this minus sign we are omitting. It is 4a sin theta by 2, 4a sin theta by 2, since a is also positive for a parabola. So this is the answer. Now in particular, if theta is pi by 2, it may be asked find the radius of curvature at the point where theta equal to pi by 2. So in that case, here if we put theta equal to pi by 2 in the final answer, pi by 4, sin pi by 4 will be coming 1 by root 2, so my answer will be 2 root 2a. But instead of calculating these things in the beginning, also we can put the value of theta in x dash, y dash, x double dash, y double dash. So that's why x dash is this time a into 1 minus cos theta, means it is cos pi by 2 is 0. So a, y dash is sin pi by 2 is 1, means a again, x double dash is a sin pi by 2 again, a, y double dash is a cos pi by 2, it was cos theta, so a cos pi by 2, cos pi by 2 is 0, so y double dash is 0. Therefore rho becomes s square plus s square to the power 3 by 2 by y double dash is 0, that's why 0 minus x double dash is a, y double dash is also a, so it is 2a square to the power 3 by 2, means 2 root 2 a cube by minus s square minus 2 root 2a, but rho is measured positive, so rho is 2 root 2a. Okay, next example number 8. Find the radius of curvature at any point r theta of the curves. These two curves given, polar curve, equation of the curve given in polar form, so we shall use the formula for radius of curvature in polar coordinates. Number 2 is kept as homework. Answer is also given, 4 by 3a sin theta by 2. And number 1, let us see. R equal to a into 1 plus cos theta. R1 means dr by d theta is minus a sin theta. The derivative of cos theta is minus sin theta. R2 means d square r by d theta square. Again differentiate cos sin theta. That will be with respect to theta is cos theta. So minus a cos theta. Therefore required radius of curvature is rho equal to, in polar coordinate this is the formula, r square plus r1 square to the power 3 by 2 by r square plus twice r1 square minus r2. So value of r is s square into 1, r is a into 1 plus cos theta, square is there, so s square into 1 plus cos theta square plus r1 square, r1 is minus a sin theta, so it is squaring s square sin square theta we get to the power 3 by 2 by r square, s square into 1 plus cos theta square, then 2 r1 square, 2 into s square sin square theta, and then r2, value of r is a into 1 plus cos theta and r2 is minus a cos theta, so this minus will make it plus. Okay, so in the numerator what we see, s square common means a cube common, because there is a 3 by 2 power, and then expanding this 1 plus cos theta whole thing square, we get 1, there is cos square plus sin square means again 1, so it is 2 plus 2 cos theta to the power 3 by 2, and this a cube, and in the denominator s square common, so this s square a cube simplified we get a, and here is what, 1 plus cos theta square expanded, then 2 sin square theta, and here minus minus plus means cos theta plus cos square theta, so 2 sin square theta, there are 2 cos square theta also, so 2 cos square theta means 2, and there is 1, so 3, and this 2 cos theta and cos theta gives us 3 cos theta, so finally we get 3 plus 3 cos theta, so 3 common, here 2 common, and 2 common means 2 to the power 3 by 2, we have written 2 root 2. So this 1 plus cos theta to the power 3 by 2 by 1 plus cos theta again gives 3 by 2 minus 1 means half, that is root over 1 plus cos theta. So 2 root 2 by 3 a into root over 1 plus cos theta, and 1 plus cos theta is 2 cos square theta by 2, trigonometry formula. So we get finally root 2 means 4 by 3 a cos theta by 2. This is the radius of curvature at any point for this curve. And one note, we observe that rho we have got this line 2 root 2 by 3 a root over 1 plus cos theta. Now this a let us take as root a inside and 1 root a outside. So this a into 1 plus cos theta actually r, given equation of the curve r equal to this. So and this value let us take as k into root r, where k means 2 root 2 by 3a. This is a constant. Therefore rho equal to k into root r, rho equal to constant into root over r, that is rho varies as root over r. So question will be like that, prove that radius of curvature at any point of this curve is proportional to root over r. So done. Example number 9. Find radius of curvature of the following curve at the indicated point. R equal to a sin n theta at the pole, that is at r equal to 0. R equal to 0 gives the pole. Pole means origin in the Cartesian system. We call it pole in polar system. R square equal to s square cos 2 theta at the point a comma 0, that is when theta equal to 0. This is left as an exercise homework. Answer rho radius of curvature is a by 3 given. Roman 3, r equal to l by 1 plus e cos theta at the point theta equal to pi, where e is a constant lying between 0 and 1. This is actually polar equation of conic, and here e less than 1 means that's why it is ellipse. Okay, let us do number 1 first. R equal to a sin n theta. Therefore r1 means dr by d theta is minus sin n theta, derivative is cos n theta into n. This is not minus, this should be plus. This should be plus. Derivative of sin n theta is cos n theta into n. So it is na cos n theta with plus n. Then r2 means d square r by d theta square. So again derivative of cos n theta is minus sin n theta. So that's why minus comes here. Sin n theta, another n multiplied. So it is n square a sin n theta. Okay. Now at the pole, that is at r equal to 0, we see that r0 a sin n theta 0. A sin n theta 0 means sin n theta 0, and sin n theta 0 means cos n theta is plus minus 1. It may be plus 1, may be minus 1. When sin x 0, then cos x is plus 1 or minus 1. Therefore r1 is actually na cos n theta. Cos n theta is plus minus 1, so you have written plus minus na, and r2 is 0 because sin n theta 0. Therefore required radius of curvature is rho equal to r square plus r1 square to the power 3 by 2 by r square plus 2 r1 square minus r2. This is the formula in polar form. Then r is 0, r1 square 3 by 2, so it is only r1 cube. r0, this r also 0, so only 2 r1 square, so r1 cube by 2 r1 square, and that gives us r1 by 2, means half r1, but r1 is plus minus na, and since rho is measured positive, so we take rho as half na. This is the answer, radius of curvature. And Roman 2 exercise homework, and Roman 3 let us do. R equal to L by 1 plus E cos theta. L constant, E constant. L is actually semilateral rectum of the conic. Therefore R1 is dr by d theta. So L by 1 plus E cos theta derivative is minus L by 1 plus E cos theta square into derivative of 1 plus E cos theta with respect to theta is minus E sin theta. Okay. And that becomes minus minus plus a league sin theta by 1 plus E cos theta square. Okay, now r2 is d square r by d theta square. So a league constant, keep it, u by b, sin theta by 1 plus E cos theta square. So u by b derivative 1 plus E cos theta to the power 4 into in the numerator cos theta, derivative of sin theta is cos theta, derivative of numerator to be taken first, cos theta, and 1 plus E cos theta square remains denominator, minus sin numerator remains sin theta, then derivative of 1 plus E cos theta square is 2 into 1 plus E cos theta into derivative of 1 plus E cos theta is minus E sin theta. Okay, and when theta is pi, our question is here we have to find radius of curvature at the point theta equal to pi. So when theta is pi, r is L by 1 plus E cos pi, cos pi is minus 1, so it is L by 1 minus E. R1 is in terms of sine, in the numerator sin pi is 0, so that's why r1 is 0. R2 is LE into, see here is sin theta, so sin pi is 0, so we are not writing this part 0, and here cos pi is minus 1 and 1 minus E, because cos pi is here minus 1, so 1 minus E square minus 0 by 1 minus E to the power 4, so finally it is LE by 1 minus E square, because to square and 4 we can simplify. Cos pi minus 1, sin pi 0 used. So R1 R2 value obtained at the point theta equal to pi by pi. Therefore required radius of curvature is rho equal to, formula for radius of curvature in polar coordinates we have used here. Value of r is L by 1 minus c, square r1 is 0, and r is L by 1 minus c, so here square is there, and r1 is 0, value of r, then value of r2 is LE by 1 minus c square with a minus sign. So that's why this becomes plus. Now this is L by 1 minus c to the square to the power 3 by 2 means cube, L by 1 minus c square common, here 1, here E by L by 1 L square, so L by 1 minus c square you have taken common, so it is 1 plus E by 1 minus c. If we take LCM, it is 1 minus c plus E by 1 minus c, means 1 by 1 minus c, so this 1 minus c gets cancelled, final answer is L. So radius of curvature is L at the point theta equal to pi. Example number 10. For any polar curve r equal to f of theta, prove that r by rho equal to sin phi into 1 plus d phi by d theta, where phi is the angle between the radius vector and tangent to the curve at the point r theta, at which radius of curvature is rho. R theta is any point on the curve. At that point radius of curvature is rho, and at that point angle between radius vector and tangent is phi. In polar coordinate, r and theta are coordinates. R is called radius vector and theta is called vectorial angle. And there is a standard result. If phi is the angle between radius vector and tangent, then we know tan phi equal to r d theta by dr. This is a standard result, so we have used here tan phi equal to r d theta by dr, standard result. And d theta by dr means we can write it 1 by dr by d theta, that is r by r1. Dr by d theta is r1. So tan phi is r by r1. See, you can use this triangle. R by r1 is tan phi. So hypotenuse is root over r square plus r1 square. Therefore, sin phi will be r by root over r square plus r1 square, and cos phi will be r1 by root over r square plus r1 square. Now, tan phi equal to r by r1. And in the question to be shown is d phi by d theta is there. So differentiating with respect to theta, this tan phi equal to r by r1. If we differentiate with respect to theta, tan phi derivative will be sec square phi into d phi by d theta by chain rule. And right side is u by v. So it is v square means here r1 square, r1 into derivative of numerator dr by d theta minus r into numerator into derivative of denominator. But dr by d theta is r1, so it is r1 square, and dr1 by d theta is r2, second derivative. So r2 and denominator is r1 square. Now sec square phi when comes to the right side, it becomes 1 by sec square phi means cos square phi. But cos square phi value we have seen cos phi value is r1 by root over r square plus r1 square. So cos square phi will be r1 square by r square plus r1 square. Substitute it here. Then r1 square, this r1 square gets cancelled, and what we get? R1 square minus r2 by r square plus r1 square. Now as per question, what we have to show? Sin phi into 1 plus d phi by d theta. So we have added 1 plus d phi by d theta. Add 1 to the right side also. Take LCM and get r square plus 2r1 square minus r2 by r square plus r1 square. Now multiplied by sin phi as in the question. So value of sin phi is r by root over r square plus r1 square. We have seen already there. So that value is used here. And then these two terms gives us r square plus r1 square to the power 3 by 2. Here power is half, here is 1, so it is 3 by 2, and numerator is r square plus 2 r1 square minus r2. But we know rho equal to r square plus r1 square to the power 3 by 2 by r square plus 2 r1 square minus r2. So this is actually reciprocal of rho. So we have written 1 by rho here. Rho means radius of curvature. So r by rho. Therefore r by rho is sin phi into 1 plus d phi by d theta. Proved. Now we see radius of curvature at origin by Newton's method. How to find radius of curvature at origin by Newton's method without finding derivative, without using dy by dx, d square by dx, etc. One easy method, but in some special case only. So what is the method? If a car passes through the origin, and either x-axis or y-axis is a tangent to the curve at origin. That is important. Either x-axis is a tangent or y-axis is a tangent to the curve at origin. Then the radius of curvature at origin is given by, this is Newton's method, rho equal to limit x square by 2y as x tends to 0. If x-axis is a tangent at origin. This will be the formula for radius of curvature. If x-axis is a tangent at origin, limit x as x tends to 0 of the expression x square by 2y. But if y-axis is a tangent at origin, then the rho will be given by limit y square by 2x as y tends to 0. Or you can write the same expression, limit y square by 2x as x tends to 0, because the curve passes through the origin. So when x tends to 0, y automatically tends to 0. So y tends to 0, x tends to 0 gives the same result. Okay, so let us see the proof how, for Roman 1 at least. Let x-axis is a tangent to the curve at origin, then dy by dx 0 at origin. X-axis, slope of x-axis is 0, that's why dy by dx is 0, because x-axis is a tangent. Therefore radius of curvature at origin is given by rho equal to 1 plus dy by dx square to the power 3 by 2 by d square by dx square. But dy by dx is 0, so it is only 1 by d square by dx square. Of course we have to assume here d square by dx square is not 0. So rho becomes 1 by d square by dx square, where value of d square by dx square at origin is used, and it must be non-zero. Now let us take that limit as Newton has taken. Limit x square by 2y as x tends to 0 is 0 by 0 form. Why? When the curve passes through the origin, when x is 0, y is 0. When x tends to 0, y also tends to 0. So 0 by 0 form. You can use L'Hospital's rule. Means differentiate numerator. Derivative of x square is twice x. Derivative of y is here dy by dx. So 2 dy by dx. 2 gets cancelled. This is by L'Hospital's rule. When a limit in the form 0 by 0, we can differentiate numerator and denominator separately. So x by dy by dx. Now this is again in 0 by 0 form. Why? Because dy by dx is 0 when x is 0. So it is again in 0 by 0 form. So again we apply L'Hospital rule. It will be derivative of x is 1 and derivative of dy by dx is d square y by dx square. So limit 1 by d square y by dx square as x tends to 0. Now suppose in the expression we have substituted x equal to 0 and we have got 1 by d square y by dx square. And that is rho. Already we have seen rho is 1 by d square by dx square. Of course here the value of d square by dx square at origin is used. We have taken the limit, suppose. So rho equal to limit x square by 2si as x tends to 0. And proved, this result is proved, and similarly Roman 2 can be proved. You can see. Now let us see some examples based on Newton's method. Find the radius of curvature of the following curves at origin. So 4 curves given. We shall see solution of 2 here, and 2 will be left as exercise. So number 1, 2x to the power 4 plus 3y to the power 4 plus 4x square y plus xy minus y square plus 2x 0. This is the curve given. Now if x is 0, y is 0, left side becomes 0. So clearly the curve passes through the origin, first condition. Now we have to test whether x-axis is a tangent or y-axis is a tangent. Then only we can apply Newton's method. So how to test x-axis or y-axis is a tangent? Now let us put x equal to 0. X equal to 0 means equation of y-axis. If I put x equal to 0 in the equation of the curve, what I get? 3y to the power 4 minus y square equal to 0. Okay. 3y to the power 4 minus y square equal to 0. So y square common, 3y square minus 1 0. So we get either y square 0 or 3y square minus 1 equal to 0. So we get y square equal to 0 means this is a quadratic equation in y. So two roots are equal. I have written 0, 0. Both the roots are equal roots. That is highlighted, important. And from here we get y equal to plus minus 1 by root 3. These roots are not repeated. So y 0, 0 means equal roots. Therefore the line x equal to 0 means y-axis meets the curve in two coincident points. Important. See, two coincident points at origin. The line x equal to 0 means y-axis meets the curve number 1, given curve, in two coincident points because roots are equal at origin, and that is y-axis is a tangent to the curve at origin. Definition of tangent is what? If a straight line meets a curve in two coincident points, then the curved line is called a tangent to the curve. So solving, we should get equal roots. We have got equal roots at origin, therefore x equal to 0 means y-axis is a tangent. Okay. Therefore by Newton's method, the radius of curvature of the curve at origin is given by rho equal to limit y square by 2x y tends to 0, or you can write x tends to 0 also. This is second one in the formula you have seen. This is second one, Roman 2. Y-axis is a tangent. If y-axis is a tangent, then it is limit y square by 2x y tends to 0, or you can write limit y square by 2x x tends to 0. So now we have to find the limit y square by 2x from where? From the equation of the curve. We have to find the limit of this expression. So from 1 means equation of the curve again written, and we need y square by 2x. That is y square by x is the important expression. So we divide the whole equation by x, divided by x. So it is 2x cube. It is 3y to the 4 by x. It is 4xy divided by x. It is only y. It is y square by x. It is 2. Now we need y square by 2x. So some adjustment is done here. 3y to the power 4. I have written 6y square into y square by 2x. If we simplify, we shall get 3y to the power 4 by x. Okay. Then 4xy. Okay. Then y square by 2x. We have written y square by 2x into 2. Now let us take limit as y tends to 0, or you can write as x tends to 0. In this line number 2, what we get? When y tends to 0, x also tends to 0 because the curve passes through origin. So first one is 0, second one is 0. 6y square will be 0 into rho. Y square by 2x limit is rho. So this is rho, means radius of curvature. And then 4 into 0 because y 0 tends to 0. Then again y 0. Then 2 into y square by 2x. This limit of y square by 2x is rho, twice rho, plus 2 equal to 0. So what do you get? Twice rho equal to 2. If we side change, 2 rho equal to 2 means rho equal to 1, which is required radius of curvature. See, in this example, we have not found the value of dy by dx. We have not found the value of d square by dx square, but we have found the radius of curvature at origin by Newton's method. Now, Roman 3. 4x to the power 4 plus 3y cube minus 8x square y plus 2x square minus 3xy minus 3xy square plus 8y0. This is the curve given. Clearly, the curve passes through the origin. If I put x0, y0, the equation is satisfied. So, curve passes through the origin. Now, you can check with putting x0 or y0. Here we have some trial is to be done. So if I put y0, then number 1 becomes 4x to the power 4 plus 2x square 0. Okay, so x square common, 2x square plus 1 0 means x square 0. Here 2x square plus 1 is greater than 0 for any real value of x. Okay, so x square is 0 means x 0 0 equal roots. Therefore the line y0 means x-axis meets the curve 1 in two coincident points at origin, and hence x-axis is a tangent to the curve at origin. Therefore by Newton's method, radius of curvature at origin is given by rho equal to limit x square by 2y this time, x square by 2y. So from the equation number 1, we again write the equation 1 and we find the limit of x square by 2y. Means this equation, let us divide by y first. We have divided by y. Here is a x square, so x square by y will be coming. And then some adjustment, means here x to the power 4, so I have written 8x square into x square by 2y. This 8 and 2 will adjust and we shall get 4. So x square by 2y. This is the expression for radius of curvature when we take limit. 3y square divided by y. So 3y cube will become 3y square. Here it is 3y square. 8x square divided by y. So it is 8x square remains as it is. Here x square. So it is x square by y. Here you had to write x square by 2y. And that's why this 2 written as 4. Minus 3x because divided by y here. Then 6y square becomes 6y as it is. And 8y becomes 8. Now if we take limit as x tends to 0. We get from this line number 2. What we get? This is 8x square, limit will be 0. Okay. 0 into. This is rho. Limit x square by 2y is rho, so 0 into rho plus 0, y is 0. When x 0, y is also 0. Minus 8 into x square, this is 0. Here plus 4 into this is rho. X square by 2y limit is rho. Minus 3x becomes 0. Minus 6y also 0 because when x 0, y is also 0. Plus 8 0. So what you get from this line? 4 rho plus 8 0 means rho will be minus 8 by 4 minus 2. But rho is measured positive, so rho equal to 2. We shall take 2, which is required radius of curvature of the curve at origin. And Roman 2, hint given, y-axis is a tangent at origin. By Newton's method, rho will be this, answer will be 3. And Roman 4 also hint is given, x-axis is a tangent at origin. By Newton's method, rho is this limit, and that is 1 by 4. So thank you for today.